Okay, good afternoon to one and all. This is Gopi Krishna, Assistant Professor, Department of CSC from Chevrolet Engineering College. So, subject is compiler design. Today's topic is grouping of phases into passes and the evaluation of programming languages. So, these two topics discussing today. So, first one is the grouping of phases into passes and evaluation of programming languages. So, here. So in previous class we are discussing structure of a compiler or phases of a compiler. So this is a symbol table. All of you visible to my screen?
సార్
సరిగ్గా కనపట్లేదు సార్.
Good.
కనబడుతుంది సార్.
All right. So in this phases of compiler or structure of a compiler, we are using symbol table. One symbol table and error handler. Okay, and 6 phases. So first one is the lexical analysis, second one is the syntax analysis, and third one is semantic analysis, fourth one is intermediate code generation, and fifth one is code optimization, and sixth one is the code generation. Okay, these are the 6 phases of a compiler. So in this example, we are taking the example is position is equals to initial value plus rate into 60. So where 60 is the constant value. So this statement is given to the lexical analysis. This statement is given to the lexical analysis. This lexical analyzer can convert, can read each and every character that is present in a statement and that is converted a given statement into stream of tokens. Okay, so stream of tokens గా lexical analyzer అనేది కన్వర్ట్ చేస్తుంది ఇచ్చిన source program ని. So after getting the stream of tokens by the lexical analyzer and it is given to the syntax analyzer. So stream of tokens, so it is in the form of ఎలా ఉంటుంది token class comma attribute. So this is the format, token class comma token class comma attribute. So we are converting that lexical analyzer into stream of tokens. So that is id comma 1 equals to id comma 2 and plus id comma 3 into 60. So that is the given. Okay, so that syntax analyzer take an input from the output of lexical analyzer, that is converting that syntax analyzer is used to convert the given stream of tokens into syntax tree or a parse tree. Okay, so syntax tree or a parse tree, so by the lexical analyzer. So we can get the syntax tree or parse tree by the input is taken from the output of lexical analyzer and it is converted into parse tree or syntax tree by the syntax analyzer. So after converting the given stream of tokens into parse tree or syntax tree, that is given to input to the semantic analyzer. So this semantic analyzer is used to verify that that syntax tree is correct one or not. So if it is correct, if it is correct, then it is moved to the next phase, and if it is not correct, then notify the errors to the user. Okay, so semantic analyzer can modify the given syntax by using context free language, based on the context free language rules. So this is semantically verified by the syntax tree or parse tree. That output is given to the input of intermediate code generator. So in this intermediate code generator, what is the చెప్పమ్మా ఎవరు హలో ఎనీ డౌట్? Right. Okay, next one, intermediate code generation. So the output is taken from the semantic analyzer, that is input to the intermediate code generator. So we are converting the intermediate code generator to the given syntax tree or parse tree semantically verified step. Then it is converting the given pass tree or syntax tree. That is, by using the tree address code, we can generate the intermediate code generation. So we are converting the given pass tree or syntax tree into tree address code. So in the intermediate code generation. So after getting the output of intermediate code generation, that is given to input to the code optimizer. That is, the role of code optimizer is there any unwanted statement or unwanted unwanted lines that are present in the intermediate code generation? Those lines and those statements can be removed by the code optimizer. Then finally, output of code optimizer, that is output of code optimizer, that is given to the input of code generator. So the code generator is used to convert the given statements, that is converted to the assembly level language based on the some functions. So we are using assembly level language addition, subtraction, multiplication by using a add, mul, div. So that type of statements, those can be converted by the code generation. So these are the 6 steps we can convert a given source program into assembly level language code. So that is the, we are using the 6 pages. So those after getting the code generation, these statements that can be stored in the symbol table. Okay, so this is the phases of a compiler or a structure of a compiler. Okay, so this is the 6 pages of a compiler or structure of a compiler. So the next concept is here we are using conceptual structure or the grouping of phases into passes. Okay, so what is the difference between a phase and a pass? So for example, we are considering a phase. So phase means it is taken as output from the above phase and consider as input, and we are converting that input into some rules, based on some rules, and given the output. That output is given to next phase. Okay, that is the phase. And what is the pass? Pass means we are having traversal of a compiler, traversal of a compiler through the entire program. So that means a pass refers to the traversal of a compiler through refers to traversal of a compiler through the entire program. That is a pass. Pass means we are having more than one phase, and we are phase means a phase of a compiler is a distinguishable stage which takes the input from the previous stage. It takes the input from the previous stage, and it is processes and given output to the output, that is find the output, and that is given to the next phase. Okay, so that is the pass, sorry, phase. So these are the difference between phases and into passes. So what is the difference between phase and pass? Pass means the evaluation of entire program is using the passes, and phase means it is taken as input from the before previous stage, and processes and find the output, and it is given to the next stage. That is called the phase. So this is the main difference between the phases and passes. Okay, so here the conceptual structure or the grouping of phases into passes. So here the given we are having 6 phases of a compiler. So those 6 phases can be divided into 2 passes. So those passes are here front end and back end. So we are using front end and back end. So in front end we are using 4 pages. So that is lexical analysis, syntax analysis, semantic analysis, and intermediate code generation. These four are the front end passes. Okay, and we are using back end passes. So last two, code optimization and code generation, comes under the backend path. So here we are taking the source code, we are taking the source code, and that is given to the front end. So in this front end we are having 4 pages. So those 4 pages are lexical analysis, syntax analysis, semantic and intermediate code generation. So in this phase, front end we are passing the processing and get the output, and that is given to the intermediate representation that is given to backend. So in this backend we are having two phases, that is code optimization and code generation. So those are taken input to the intermediate representation and process then get the output, that is the target code. So this is the general conceptual structure or grouping of phases into passes. So in this we are using two passes for defining six phases. Okay, so this is the source code, and first one is the front end. We are having analysis phase. So front end is also known as analysis pass అంటారు, అలాగే బ్యాక్ ఎండ్ వచ్చేసరికి సింథసిస్ పాస్ అంటారు. ఓకే, దీస్ ఆర్ ద two passes. Those six phases can be divided into two passes. So first one is the analysis pass and second one is the synthesis pass. Okay, so in this front end analysis pass and back end we are using synthesis pass. So these are the grouping of phases into passes. Okay, so in this we are taking the source code and it is sent to the front end. So in this front end we are having four pages, and 511 511. Okay, so this is a given source code and we are having the front end, and in this front end the process is going on, and it is represented to the back end, intermediate representations and to the back end, and finally get the target code. So in this we are having two passes as analysis pass and synthesis pass. So this is the grouping of phases into passes. So here in this analysis path or front end, in this synthesis phase or back end. So in this first one analysis phase we are having four phases. So first one lexical analysis, syntax analysis, semantic analysis and intermediate code generation. In this synthesis phase, so we are having code optimization and code generation. So in this analysis phase, all of you know lexical analysis. So what is the role of lexical analysis? So we can read each and every character that is present in a source program and grouping them into sequential meaningful sequence. Those sequences are called the lexemes. So those lexemes are comes under the stream of tokens. Okay, so that is first role of lexical analysis. And coming to next syntax analysis, we can take the output of lexical analysis as input to the syntax analysis. So those stream of tokens can be converted into parse tree or syntax tree by using syntax analyzer. So after converting the given stream of tokens into syntax tree or parse tree, that is given to the input to semantic analysis. In this semantic analysis, the construction of parse tree is semantically verified or not. That means we are using some semantic type conversions, mismatches. Is there any errors that is present in that particular parse tree that can be rectified by the semantic analysis, and finally we can get the unambiguous parse tree or syntax tree that is given to the intermediate code generation. So in this we are getting the input from the semantic analysis, that is given to input intermediate code generation. That intermediate code generation we can generate three address code for the given syntax tree or parse tree. And this intermediate code generation, the best technique for the intermediate code generation is three address code. So we can convert the entire statements or entire program that is converted into three address code. Then the final result. So the in front end the final result that is given to the code optimization. So in this synthesis phase, the code optimization. So the output of code optimization that is given, the input of code optimization that is given to the intermediate code generation to the code optimization. In this code optimization we are having, so is there any unwanted statements or any unwanted lines that are present in that intermediate code generation? Those are removed by the those are removed by the code optimization and given out and given input to the code generation. So after getting the output of code optimization to the code generation, the code generation is used to convert the given statements to the assembly level language. So these 6 phases we are using the phases of a compiler. So that is converted into 2 phases, analysis phase and synthesis phase. So that is also known as front end and back end. So all of you know front end and back end. So any we can develop a compiler. So we can develop a new compiler based on particular reason. So we have all the phases. So front end is available for all the compilers. So we can change only the back end. We can change only the back end. So we can change. We can get a న్యూ కంపైలర్. సో మీరు ఒక కంపైలర్ ని డిజైన్ చేయాలనుకున్నారనుకోండి, కొత్తగా ఒక కంపైలర్ ని. సో ఫ్రంట్ ఎండ్ లో ఉన్న ప్రతి ఒక్క పేజ్ అనేది ఏమవుతుంది? సో దట్ ఈస్ present in all the compilers, and we want to change the last 2 pages. So that we are changes the last 2 pages, so we can get a new compiler. Okay, so analysis phase అనేది ఫ్రంట్ ఎండ్ అనేది ఏ కంపైలర్ డిజైన్ చేయాలన్నా సేమ్ ఉంటుంది. సో we are changing the only synthesis phase, that is back end. We can change the we can get a new compiler. ఏదైనా కంపైలర్ ని తయారు చేయాలనుకుంటే మీరు బ్యాక్ ఎండ్ లో ఉన్న కోడ్ ఆప్టిమైజేషన్ ని, కోడ్ జనరేషన్ ని మార్చుకుంటే we can get a new compiler. So these are the 2 phases, analysis phase and synthesis phase. In this analysis phase we are having 4 phases. In synthesis phase we are having 2 phases. Okay, so that is the grouping of phases into passes. So next one. So in this analysis phase, front end, so it mainly deals with linear analysis, hierarchical analysis, semantic analysis. So linear analysis means lexical analysis, and hierarchical analysis means parsing. So we can get a parse tree. And this semantic analysis, what is the semantic analysis? So the given syntax tree or parse tree that can be verified by the semantically verified or not. Okay, so this analysis phase, front end, it mainly deals with linear analysis, hierarchical analysis, semantic analysis. So in this first one, breaks up the source code, right? So what is the role of lexical analysis? So we can break the source code into pieces and imposes a grammatical structure. So that means we can take the source code and it is read each and every character and grouping of sequential meaningful sequences. Those are called lexemes. So in this analysis phase, breaks the source code into pieces and imposes a grammatical structure. So ఒక మనం కాంటెక్స్ట్ ఫ్రీ గ్రామర్ లో ఒక స్ట్రక్చర్ ఉంటుంది కదా, ఆ స్ట్రక్చర్ ని బేస్ చేసుకొని మనం ఆ స్ట్రీమ్ ఆఫ్ టోకెన్స్ ని జనరేట్ చేసుకుంటాం. సో దట్ ఈస్ ద లెక్సికల్ అనాలిసిస్ ఫేజ్, దట్ ఈస్ ఆల్సో నోన్ యాజ్ లీనియర్ analysis. So next one, using this creates a generic intermediate representation IR of the source code. So in this front end it is given to the intermediate representation. In the previous slide we are the intermediate representation of a source code, and then checks for syntax or semantics and provides informative messages back to user in case of any errors, right? So we are constructing a parse tree or syntax tree that is semantically verified or not. So if it is verified semantically verified, there is no errors, so then move to the next stage, intermediate code generation. If we are getting any errors, that is sent to the back to user in case of any errors. So those are back to user in case of any errors. Okay, సో సింటాక్స్ ట్రీ అనేది అంబిగ్యూటీ లేకుండా అన్అంబిగ్యూస్ గా వస్తే నెక్స్ట్ ఫేజ్ కి వెళ్తుంది, లేకపోతే ఎర్రర్స్ ఉంటే దట్ ఈస్ రిపోర్ట్ టు ద యూజర్. ఓకే, next we'll see a symbol table. So after intermediate code generation, those are stored in a symbol table, and those symbol table information can collect the source program. So build a symbol table to collect and store information about the source program. So that is the next one. So in this analysis phase, we are mainly deals with lexical analysis, hierarchical analysis, and semantic analysis. Okay, so what is lexical? So breaks the entire, so we can read each and every character that is present in a source program that can be grouping into sequential meaningful sequences. Those are called the lexemes. And next phase we are having, we can construct the syntax tree or parse tree. Then third phase we are verifying semantically. Okay, so that is a analysis phase, front end. Okay, next one. So in this synthesis phase, that is back end. So here chooses instructions to implement each intermediate representation operation. Okay, so it chooses the instructions to implement 503. So here, so it chooses instructions to implement each intermediate represent operation. So after getting the result of intermediate code generation, result of intermediate code generation, that is given to the code optimization. So it chooses instructions to implement each intermediate representation operation, and it translates intermediate representation into target code. So what is the final result of a particular statement? Intermediate target code. So we are taking the source code that is converted into target code. So here translate the intermediate representation into the target code, needs to conform with system interfaces. So is there any interfaces that are available that can be conformed with system interfaces? And automation has been less successful. Automation means so we are in a phases, in the 6 different phases. Automatically generation can be done by the context free grammars or a compiler designer. So that is has been less successful, means automation. So different of programs రాస్తా ఉంటాం కదా, ఆ ప్రోగ్రామ్స్ ని ఆ ఫేజెస్ అనేవి అండర్స్టాండ్ చేసుకోగలిగితే మనకి సక్సెస్ అనేది వచ్చేస్తుంది. లేకపోతే మనం ఆటోమేటిక్ గా పెడితే కొంచెం సక్సెస్ రేట్ అనేది తక్కువగా ఉంటుంది. ఆటోమేషన్ హ్యాస్ బీన్ లెస్ సక్సెస్ఫుల్. ద సింథసిస్ పార్ట్ constructs the desired target program from the intermediate representation. సో మనకి ఫైనల్ గా వచ్చేది ఏంటిది? టార్గెట్ ప్రోగ్రామ్. ఓకే, సో ఈ పార్ట్ బ్యాక్ ఎండ్ పార్ట్ ఏం చేస్తుంది? వీ కెన్ కన్స్ట్రక్ట్ ద డిజైర్డ్ target program from the intermediate representation. So these two are the back end phases. So code optimization and code generation. So what is code optimization? What is code generation? All of you know. Okay, so this is the back end phase. So that is first one analysis phase, and second one is the synthesis phase. We can convert phases into parses, right? Okay, so next one is the evaluation of programming languages. So the evaluation of programming languages. So here the programming languages are two types. So first one is the low level programming languages, and second one is the high level programming languages. So in this low level languages can be divided into again two parts. So first one is first generation programming languages, and second one is the second generation programming languages. In high level languages we are constructing high level languages. So we are having three different generations: third generation, fourth generation, and fifth generation. Okay, so here మా 501 ఎవరు? Five not one. Five not one.
लिखता सर
Likita. So these are the types of programming language, low level and high level. So these two types of programming languages can be divided into 5 types. So first, second, third, and fourth and fifth generation languages. So here first generation languages. So that is low level languages. So in this first generation programming language is a pure machine code, right? So first generation ante it is in the form of zeros and ones. So that is first generation. So here the first generation program language is pure machine code, that is just ones and zeros. So example, so the code is like this. We can write the program in type of this code. Okay. So for example, we are writing addition of two numbers in a machine code. So the entire program is in the form of zeros and ones. So that is zeros and ones. And next one, it is the only language understood by the computer. So ఇప్పుడు దాకా మనం కంపైలర్ తీసుకుంటే ఆ కంపైలర్ ఏం చేస్తుంది, గివెన్ సోర్స్ ప్రోగ్రామ్ దట్ ఈస్ కన్వర్టెడ్ ఇంటూ machine code, that is converted into machine code. Why? Because the computer can understand only the machine code. So English language cannot understand by the computer. By using compilers or interpreters, we can convert the source program into machine code, and that machine code can understood by the computer. So this is the one. So it is the only language understood by the computer, and programmers have to design their code by hand, then transfer it to a computer by using a punch card. For example, in nowadays we are having computers. So in previous generations, there is no computers, so small type of computers. So we can programmers have to design their code in terms of a machine code. But those machine codes can using we can send the computer by using punch cards. So programmers have to design their code by hand, then transfer it to a computer by using a punch card. So programmer అనే వాళ్ళు కంప్యూటర్ లో రాయకుండా ప్రోగ్రామ్ అనేది ఒక బై హ్యాండ్, సో ఒక పేపర్ మీద రాసుకొని ఆ కోడ్ అనేది కంప్యూటర్ కి ట్రాన్స్ఫర్ చేయాలంటే బై యూజింగ్ సమ్ పంచ్ కార్డ్, దట్ ఈస్ ద using to communicate between the user and the computer by using punch card. So here programmers have to design their code by hand, then transfer it to a computer by using punch card. So in this first generation or low level language, we are having some advantages and disadvantages. So here is the advantages. Here first advantage is code can be fast and efficient because no translator needed. Because no translator needed. 1 minute. Hello. Hello. Yes. So this is the advantages of first generation languages. So here code can be fast and efficient. So why? Because the computer can understand only the machine code, right? So కంప్యూటర్ అనేది మెషిన్ కోడ్ మాత్రమే అండర్స్టాండ్ చేసుకుంటుంది కాబట్టి, సో ప్రోగ్రామర్ అనే వాళ్ళు ఏం చేస్తున్నారు, వీ కెన్ రైట్ ద ప్రోగ్రామ్ ఇన్ మెషిన్ కోడ్, సో ఈజీ టు అండర్స్టాండ్ బై ద కంప్యూటర్. సో దెర్ ఈస్ నో నీడ్ ఆఫ్ కంపైలర్స్ ఆర్ ఇంటర్ప్రిటర్స్. సో ఎందుకంటే ట్రాన్స్లేటర్స్ ఏమి లేవు కదా, ఎందుకంటే ప్రోగ్రామర్ అనేవాడు మెషిన్ కోడ్ లోనే రాస్తున్నాడు. సో దెర్ ఈస్ నో usage of compilers or interpreters or translators. Okay, so this is the first advantage. So first one, code can be fast and efficient because no translator needed. So that is the advantage. Second one, code can make use of specific processor features such as special registers. So we can store the program by using some registers. So we are using some memory, we can store that program. So in that memory we are using some registers. So this is the advantage. Code can make use of specific processor features such as special registers. So we can store directly to the specific registers, so based on the memory. Okay, so these are the two advantages of first generation languages. So first one is the code can be fast and efficient because no translator needed. So why? Because a programmer can write the program in a machine code only. So no need of using translators. So interpreter అవసరం లేదు, కంపైలర్స్ అవసరం లేదు, ఎందుకంటే ప్రోగ్రామర్ అనే వాళ్ళు మెషిన్ కోడ్ లోనే రాస్తున్నారు. ఓకే, సో సెకండ్ వన్, code can make use of specific processor features such as special registers. Okay, so that is the second advantage of first generation languages. And so in this language we are having some advantages and as well as some disadvantages. What are the disadvantages? So here is the disadvantages of first generation languages. So first one, code cannot be ported to other systems. So portability, what is the portability? So we are writing a program in one computer that is taken to another computer. Okay, so portability అంటే మనం ఒక సిస్టమ్ లో రాసిన ప్రోగ్రామ్ అనేది ఇంకొక సిస్టమ్ కి తీసుకెళ్ళినప్పుడు సో ఆ పర్టికులర్ పోర్టబిలిటీ అనేది లేకపోతే, సో దట్ ఈస్ నాట్ సపోర్టెడ్ ద పోర్టబిలిటీ. అంటే మనం రాసిన ప్రోగ్రామ్ అనేది పోర్టబిలిటీ లేదు. మనం ఏ సిస్టమ్ లో అయితే రాసామో ఆ సిస్టమ్ లో మాత్రమే మనం a particular program ని execute చేసుకోవాలి. No, so it does not support the portability. Okay, so code cannot be ported to other systems and has to be rewritten. So rewritten చేయడానికి కూడా possibility లేదు. So why? Because so we are writing in a machine code, so that machine code can understand by that computer only. So that is the one drawback. So in nowadays we are moving platform independent languages, programming languages. So platform independent means సో సిస్టమ్ తో సిస్టమ్ సంబంధం లేకుండా మనం రాసిన ప్రోగ్రామ్ ఏ సిస్టమ్ లో అయినా, ఏ ఆపరేటింగ్ సిస్టమ్ లో అయినా యూజ్ చేసుకోవచ్చు నవ్ డేస్. సో ఇన్ ప్రీవియస్ ఫస్ట్ జనరేషన్ కాబట్టి మనకి కోడ్ అనేది ఆ కంప్యూటర్ లోనే వర్క్ అవుతుంది. సో కోడ్ కెనాట్ బి పోర్టెడ్ టు అదర్ సిస్టమ్స్ అండ్ హ్యాస్ టు బి రీరిటర్న్. ఓకే, so that is the first drawback in a first generation languages. And second one, code is difficult. So here the code is difficult to edit and update. Why? Because the code is in the form of machine code, zeros and ones. So code is difficult to edit. మనం ఎడిట్ చేయడానికి డిఫికల్ట్ గా ఉంటుంది, అలాగే అప్డేట్ చేసుకోవాలన్నా కూడా డిఫికల్ట్ గా ఉంటుంది. సో దట్ ఈస్ ద అనదర్ డ్రాబ్యాక్ ఇన్ ఫస్ట్ జనరేషన్ languages. And third drawback in it is difficult to debug the program. So what is debugging? So we are finding the errors, so it is also difficult to the program. Okay, so we are writing a program in machine code that is difficult to debugging. So we find the errors is critical. Okay, so errors ni find out చేయాలన్నా మనకి 573 చెప్పమ్మా. 573. Any doubt? So this is the third drawback of first generation languages. So it is difficult to debug the program. So these are the three drawbacks that are present in a first generation languages. So first one, code cannot be ported. So ported means portability. So it is not supporting the portability. So we can use that code in that computer only. So there no need to transfer another computer. So that is the first drawback. And second drawback is code is difficult to edit and update. So edit చేయడానికి అప్డేట్ చేయడానికి కోడ్ అనేది డిఫికల్ట్ గా ఉంటుంది, అలాగే డీబగ్ చేయడానికి కూడా కష్టంగా ఉంటుందని చెప్తున్నారు. ఓకే, సో దీస్ ఆర్ ద త్రీ డ్రాబ్యాక్స్ ఆఫ్ ఫస్ట్ జనరేషన్ లాంగ్వేజెస్. సో నెక్స్ట్ వన్ ఈస్ సెకండ్ జనరేషన్ లాంగ్వేజెస్. సో వాట్ ఈస్ సెకండ్ జనరేషన్ లాంగ్వేజెస్? సో హియర్ there are a way of describing assembly code. So in the second generation languages, so we are having to describe a language with assembly code. Okay, so there are a way of describing assembly code which uses mnemonics code like so add is used for addition, SQB is used for subtraction, MUL is used for multiplication, DIV is used for division, and MOV is used for so moving one variable value to another variable. So we are using move, etc. So this is the assembly code we are writing the second generation languages, right? So in this sorry. So it is much easier than machine code. So it is somewhat better to write a programs when compared to machine code. So machine code లో రాయటం కన్నా ఇలాగా రాసుకోవడం కొంచెం ఈజీగా ఉంటుంది. So it is much easier than machine code. So machine code is in the form of zeros and ones. Here we are using assembly code. So we are using addition. We are using ADD. So it is much easier than the machine code. And next one. Third, in assembler is used to translate. So in this we are using assembler, so we can transfer the assembly code to machine code. So assembly code నుంచి machine code convert చేయడానికి assembler ని మనం translator ని యూజ్ చేస్తున్నాం. So assembler is used to translate all into machine code. So here is the assembly code. For example, LEAA 8 add 5 SPAA JMP. So these type of statements that can be converted into object code or machine code by using assembler. So this is the second generation languages. So next one. So in this also we are having some advantages and some disadvantages. So what is the advantages and what are the disadvantages? So here advantages, the first advantage is fast and efficient due to the usage of registers. So in previous drawbacks, of special purpose registers that can be used in that drawback. Okay, so in first generation languages, here also that is the advantage. So to overcome the drawbacks in a first generation language, so that is the advantage. So efficient fast and efficient due to the usage of registers. And second one, easy to read and write compared to machine code. So it is easy to read and write. So మనం ఈజీగా రీడ్ చేయవచ్చు, అలాగే ఈజీగా రాయవచ్చు when compared to the మెషిన్ కోడ్. సో మెషిన్ కోడ్ తో కంపేర్ చేస్తే ఇది కొంచెం ఈజీగా ఉంటుందని చెప్పాం కదా. సో దట్ ఈస్ ద అడ్వాంటేజెస్ ఆఫ్ సెకండ్ జనరేషన్ లాంగ్వేజెస్, దట్ ఈస్ అసెంబ్లీ language. And what are the drawbacks of this particular second generation languages? So first one, code cannot be ported to the other system. Here also same, code cannot be ported. So portability is not supported in a second generation languages also. Okay, code cannot be ported to other systems and has to be rewritten because each processor has their own mnemonic. So why? Because so mnemonic means ADD, MUL, DIV, those type of mnemonics can be used. So because each processor has their own mnemonic. So ప్రతి ఒక్క ప్రాసెసర్ కి దానికి సంబంధించిన మెమోనిక్స్ ఉంటాయి కాబట్టి మనం దీన్ని పోర్టబిలిటీ చేయలేము అండ్ హ్యాస్ టు రీరిటర్న్. ఓకే, సో నో సింబాలిక్ నేమ్స్ ఫర్ మెమరీ లొకేషన్. సో ఇన్ దిస్ we are storing the particular program, there is no symbolic names. So symbolic names అనేవి ఏమి ఉండవు. సో ఫర్ మెమరీ లొకేషన్స్, సో మెమరీ లొకేషన్స్ లో ఏమి సింబాలిక్ నేమ్స్ అనేవి ఉండవు. సో ప్రోగ్రామ్ అనేది ఎక్కడైనా స్టోర్ అవ్వచ్చు. సో దెర్ ఈస్ నో స్పెసిఫిక్ స్పేస్ ఫర్ ద పర్టికులర్ ప్రోగ్రామ్. ఓకే, సో నెక్స్ట్ వన్, నీడ్ టు keep track of exact memory location that a piece of data is stored. So for example, ఒక డేటా అనేది స్టోర్ చేసామనుకోండి, ఆ స్టోర్ చేసిన డేటాని సో మనం ట్రాక్ చేయాలంటే కొంచెం కష్టంగా ఉంటుంది. ఓకే, సో ఎగ్జాక్ట్ మెమరీ లొకేషన్ ఫైండ్ అవుట్ చేయడానికి ఇట్ విల్ టేక్ సమ్ టైమ్. సో దట్ ఈస్ ద డ్రాబ్యాక్ ఇన్ ఏ assembly level languages or second generation languages. So need to keep track of exact memory location that a piece of data is stored, and it is not straightforward to perform loops and conditionals. Okay, so it is not a straightforward. For example, is there any loops that are present in a program? So it is not performed very well by the assembly level language, second level languages. So these are the four drawbacks that are present in a second level, second generation languages. Okay, and so in this third generation languages, so here the third generation languages, programming languages brought many programmers friendly features to code such as loops, conditionals, classes. So in this third generation and high level language, so third generation language is also known as high level languages. So here programming languages brought many programmer friendly features. So for example, programmer friendly features means so the programmer can write a program in English language. So that is the high level language. So ఎవరికైనా మనకి ఆ పర్టికులర్ ప్రోగ్రామ్ ని రైట్ చేయడానికి పాసిబిలిటీ ఉంటుంది. ఫర్ ఎగ్జాంపుల్, మీరే ఇప్పుడు ఎడిషన్ ఆఫ్ 2 numbers ని మెషిన్ కోడ్ లో రాయాలంటే రాయగలరా? రాయలేరు. సో రాయొచ్చు, బట్ వీ హ్యావ్ టేక్ మోర్ టైమ్. సో వీ కెన్ రైట్ ఏ program in machine code. So here we can we overcome the drawbacks in first generation and second generation. So we are having third generation high level languages. So the programming languages brought many programmer friendly features. So that means English language. So we can write a programs in English language. Okay, so those are the programmer friendly features to code such as loops to conditionals, classes. So classes means we are using C++ and loops and conditionals we are using in C. Okay, right. Second one, this means that one line of third generation code can produce many lines of object code. So for example, థర్డ్ జనరేషన్ కోడ్ తీసుకుంటే దట్ కెన్ ప్రొడ్యూస్ ఏ మెషిన్ కోడ్. సో సోర్స్ ప్రోగ్రామ్ నుంచి మెషిన్ కోడ్ గా కన్వర్ట్ చేస్తుంది. ఎట్లా? జనరల్ గా ప్రోగ్రామ్ కంప్యూటర్ కి అర్థమయ్యే లాంగ్వేజ్ మెషిన్ కోడ్. సో మనం రాసిన మెషిన్ కోడ్ అయితే మనకి కొంచెం కష్టంగా ఉంటుంది, కంప్యూటర్ కి ఈజీగా ఉంటుంది. సెకండ్ జనరేషన్ లో ఏమైంది, అసెంబ్లీ కోడ్ ని మెషిన్ కోడ్ కన్వర్ట్ చేయడానికి మనం అసెంబ్లర్ ని యూజ్ చేసాం. సో ఏదో ఒక టూల్ ని యూజ్ చేసి వీ కెన్ కన్వర్ట్. సో ఇన్ దిస్ థర్డ్ జనరేషన్ హై లెవెల్ లాంగ్వేజెస్ లో వచ్చేసరికి మనం ఒక ట్రాన్స్లేటర్ ని యూజ్ చేస్తాం. ఆ ట్రాన్స్లేటర్ ఏం చేస్తుందంటే మనం రాసిన ప్రోగ్రామ్ ని వీ కెన్ కన్వర్ట్ ఇంటూ మెషిన్ code. So in this main feature in this third generation, we can convert those source program into machine code, saving a lot of time when writing programs. So మనం ప్రోగ్రామ్ రాసేటప్పుడు టైం అనేది చాలా సేవ్ అవుతుంది. వై? బికాస్ ఇన్ హై లెవెల్ లాంగ్వేజెస్ వీ కెన్ రైట్ ఏ ప్రోగ్రామ్ ఇన్ ఇంగ్లీష్ లాంగ్వేజ్. సో వీ కెన్ సేవ్ more time when compared to first and second generation languages. So these can be platform independent. So in the third generation languages, platform independent. So we can write anywhere and we can execute anywhere. Okay, so these can be platform independent. So first generation and second generation languages are platform dependent. So that is code written for one system will work on another. So that is the platform independent. So that is the third generation languages. And here the compilers or interpreters are required to translate high level language into machine code. Okay na? So కంపైలర్స్ కానీ ఇంటర్ప్రిటర్స్ కానీ యూజ్ చేసి హై లెవెల్ లాంగ్వేజ్ ని మెషిన్ కోడ్ గా కన్వర్ట్ చేస్తామని చెప్తారు. ఓకేనా? సో దట్ ఈస్ ద compilers or interpreters. So compilers can convert the entire source program into machine code. Interpreter can convert the source program line by line into machine code. So that is the difference between compilers and the interpreters. So this is the third generation language. So in this third generation language, we have some advantages as well as disadvantages. So this is the third generation. So what are the advantages? So examples వచ్చేసి C, C++, Java, Basic, Fortran, PL, Algol, APL. So these are the examples of third generation language. So C, C++, Java, base beginners all purpose symbolic instruction code, Fortran. So these are the examples for the third generation languages. So here are the advantages. What are the advantages of third generation languages? So here it is a hardware independent. So hardware independent means we can store the program in a computer. So we can run a program. ఆల్రెడీ చెప్పుంటారు ఓఎస్ లో ఒక ప్రోగ్రామ్ ని మనం రన్ చేయాలంటే ఆ ప్రోగ్రామ్ ని ఫస్ట్ ర్యామ్ లోకి తీసుకుంటుంది, ర్యామ్ లో నుంచి ఎగ్జిక్యూట్ చేసి స్టోర్ చేసుకుంటుంది. ఫర్ ఎగ్జాంపుల్ వీ వాంట్ టు రన్ అనదర్ ప్రోగ్రామ్, execute another program, that program can be saved into hard disk and then other program can be taken into RAM. So this is the hardware independence, can be easily ported to other systems and processors. So this is the advantage, hardware independent. సో మన హార్డ్వేర్ ఇండిపెండెంట్ అంటే ఒకసారి సేవ్ చేస్తే ఆ ప్రోగ్రామ్ అక్కడే ఉంటుంది. సో ఎప్పుడైతే ఎగ్జిక్యూట్ చేయాలనుకుందో అది ర్యామ్ లోకి వచ్చి ఎగ్జిక్యూట్ జరుగుతుంది. సో ఇంకో ప్రోగ్రామ్ ఎగ్జిక్యూట్ చేయాలంటే ఆ ప్రోగ్రామ్ అనేది ర్యామ్ హార్డ్ డిస్క్ లో సేవ్ అయిపోయి మళ్ళీ ఇంకో ప్రోగ్రామ్ అనేది ర్యామ్ లోకి వస్తుంది. ఓకే, సో హార్డ్వేర్ ఇండిపెండెన్స్ కెన్ బి ఈజీలీ పోర్టెడ్. సో పోర్టబిలిటీ అనేది సపోర్ట్ చేస్తుంది. ఓకే, సో నెక్స్ట్ advantage, time saving. So we are writing a program in machine code is very difficult when compared to writing in English language. Okay, so we can save the time and programmer friendly. So programmer friendly means so programmer ki comfortable, we can write a program in a English language, it is very comfortable to the programmer, and one line of third generation is equivalent of many lines of first and second generation. సో ఒక లైన్ కనుక మనం థర్డ్ జనరేషన్ లాంగ్వేజ్ లో రాసామనుకోండి, సో అది ఫస్ట్ జనరేషన్ కానీ సెకండ్ జనరేషన్ కానీ తీసుకుంటే మనకి నంబర్ ఆఫ్ లైన్స్ అనేవి ఫస్ట్ జనరేషన్ సెకండ్ జనరేషన్ లో ఉంటాయి. సో దోస్ లైన్స్, ఫర్ ఎగ్జాంపుల్ ఒక 5 లైన్స్ ఒక స్టేట్మెంట్ అనుకో, థర్డ్ జనరేషన్ లో ఆ 5 లైన్స్ ని మనం ఒకే లైన్ లో రాసుకోవచ్చు అని చెప్తున్నారు. ఓకే, సో దీస్ ఆర్ ద advantages of third generation high level languages. And what is the disadvantage? So here also one disadvantage. So what is code produced might not make the best use of processor specific features unlike first and second. Okay, so code అనేది మనం ప్రొడ్యూస్ చేసిన కోడ్ we can get a best పర్ఫార్మెన్స్. సో బెస్ట్ ఫీచర్స్ కనుక ఇచ్చింది లేనిది అనేది మనకి ఫస్ట్ జనరేషన్ కి సెకండ్ జనరేషన్. సో ఫస్ట్ జనరేషన్ అయినా మనకి కోడ్ అనేది ఎగ్జిక్యూట్ కోడ్ జనరేట్ చేస్తుంది, అంటే ప్రోగ్రామ్ ని ఎగ్జిక్యూట్ చేస్తుంది. సో అది అవుట్పుట్ ఇస్తుంది, ఇక్కడ అవుట్పుట్ ఇస్తుంది. సో డిఫరెన్స్ ఏంటంటే టైం సేవింగ్ ఇవన్నీ మనకి వస్తాయి. సో డిసడ్వాంటేజ్ ఏంటి? Okay, so this is the disadvantage of third generation languages, and here are the fourth generation. So we are discussing in the next class. Okay.